is we're going to calculate something called a formal charge. Formal charge. Guys, you can think of formal charge. It's like electron bookkeeping. Okay? That's what formal charge is. Electron bookkeeping. Formal charge can help you decide which structure is the best structure, because sometimes when you draw these, you might have more than one that fits the rules. More than one uses the valence electrons and everything's got an octet, but they're different. Which one's the best structure? You would use formal charge to do that. So first I'm going to tell you how you calculate a formal charge, and then I'll show you how it tells us which is the better structure. Okay? Here comes a little bit more of that math, but no calculators. To calculate a formal charge, you simply take the valence electrons minus the electrons in the Lewis structure and that gives you the formal charge. Let me tell you what that means. When I say valence electrons, well, hang on. When you calculate a formal charge, that will be calculated for each atom in your structure. Okay? It's not, you don't do one charge for the whole structure. You do a formal charge for each atom in the structure. When I say valence electrons, I'm talking about when we go to the periodic table and we look up carbon. According to the periodic table, carbon has 4 valence electrons. So that's what that means, valence electrons. Okay? Then when I say it's minus electrons in the Lewis structure, well, I'm going to show y'all what I mean by that. I'm going to redraw carbon tetrachloride here. This is the exact thing that we drew just a second ago. And I'm going to calculate the formal charge. Now, when we counted octets, like there's chlorine's octet, right? And then there's carbon's octet. I'm only going to draw that one to show you what I'm talking about. When you counted octets, this bond right here, you counted twice. You counted it to satisfy chlorine's octet, and you counted it to satisfy carbon's octet, right? When you draw formal charges, you can't do that. That bond, that line, how many electrons is that? That's 2. When you do formal charge, you've got to split those 2 electrons and give 1 to carbon and 1 to chlorine. Okay, so let me show you what I mean. To start off, I'm going to calculate the formal charge of this carbon. The formula says I take the valence electrons. Well, how many valence electrons should carbon have? 4. Get that from the periodic table. Minus. The formula says I subtract out the electrons in the structure, but I just told y'all that when you look at the bonds, you've got to divide them between the 2 atoms in the bond. Another way to think of that is you just count each bond one time. So do you see that in this structure, carbon has 1, 2, 3, 4 electrons? Because the electrons in that bond are divided evenly. So I subtract out 4. The formal charge for carbon is 0. Okay? Now, I'm going to go over here on the left. I'm going to start with this chlorine, and we'll work our way around. According to the periodic table, how many valence electrons should chlorine have? 7. How many does that chlorine in that structure have? Count the dots, and then count the bond one time. That chlorine has 7, doesn't it? So its formal charge is 0. Now I'm going to go to the chlorine on the bottom. How many valence electrons should chlorine have? 7. How many does this structure show it having? 7. Its formal charge is? 0. Now I'm going to keep working my way around counterclockwise. The chlorine on the right, what's its formal charge? 0. The chlorine on the top, what's its formal charge? 0. Okay? That's how you would do a formal charge. Now, what's the next structure we drew? Water?
Yeah.
All right. I'm going to redraw water here. Y'all take a second and calculate the formal charge for each atom in water, and then I'll write it up here. Got it? I'm going to start with this hydrogen. Valence electrons, hydrogen should have 1. How many does that hydrogen have?
1.
1, so it has a formal charge of?
0.
0. Moving to the oxygen. According to the periodic table, oxygen should have
6.
6. How many does it have in that structure?
6.
6 for a formal charge of 0. Then going to the other hydrogen. According to the periodic table, it should have 1. In this structure, it has 1 for a formal charge of 0. You got formal charge, okay? Any questions? It's not always going to be 0. Good question. But I told you guys that formal charge is like electron bookkeeping, right? In the first two we've done, in carbon tetrachloride, everything was 0. And in water, everything was 0. The closer, if they're all 0, that means that's a really good structure. Now, water could have been, for starters, H2O has no charge, right? It's neutral. The sum of all the formal charges has always got to equal the charge of whatever you're dealing with, okay? So water was neutral. These add up to be 0. But do you see that had they been like 0, -1, and +1, that would still add up to be 0? Do you see that? Okay. Carbon dioxide, I've already drawn up here. That's what we had for CO2. Can y'all do formal charges on that one? Talk me through it. This oxygen, how many should oxygen have? 6. How many does that oxygen have?
6.
Okay, 0. The carbon, how many should it have? How many does that carbon have? And then the other oxygen? 0. Adds up to be 0. Okay? Now look at this structure, y'all, for CO2. When we drew it, the first thing we did is add up valence electrons, yes? How many electrons did we have to use in drawing carbon dioxide structure? We had 16 to use. Look at this right here at the bottom. Did I use 16 in that one?
Yeah.
That uses 16. Okay. Does everything have an octet in that one?
Yes.
Mm-hmm. Do you see that what I just drew, the answer to both of those little check questions are yes. Yes, I use 16. Yes, everything has an octet. So how am I going to decide that one at the top or the one at the bottom, which one's better? Calculate a formal charge for this one at the bottom. Uh-huh. I'm going to say 6 minus what for this one on the left? Do y'all see that it's 6 minus 5? Do you see that? Because the dots, 1, 2, and then the lines, 3, 4, 5. 6 minus 5. What about the carbon in the middle? What minus what?
4 minus 1 equals 0.
It's 4 minus 4. What about the oxygen on the right?
6 minus 7, so it gives you -1.
6 minus 7 is -1. You okay with those three formal charge numbers? Now, formal charge can be used for electron bookkeeping. In both of those, the total of all the formal charges adds up to be 0. And it should, but which one's the better structure?
The one at the top.
The one at the top where they're all 0, as opposed to the one at the bottom where I've got a +1 and a -1. That's how I would know the one at the top was the better structure. Does that make sense?
And you couldn't do that on both sides of it.
You could.
But it would be +1 on both sides, wouldn't it? If
On-
you did it, the triple bond.
Oh, well, you wouldn't do that because then carbon would have way more than an octet.
Right.
Yeah.
So,
Now, something else I want to point out to you guys about formal charge. This goes back to what we did last week. Last week, we just took an element and we drew a Lewis dot symbol. Remember doing that? So, for example, oxygen, there's an O, and O has 6 valence electrons. So for O, we did 1, 2, 3, 4, 5, 6, right? That's the Lewis dot symbol for the element. And I told you guys that whenever you look back at the Lewis dot symbol, anywhere where you have 1 electron, what did I tell you about that? That was the number of bonds that it wanted to form, right? So how many bonds does oxygen like to form? 2, because it has a single dot and a single dot. Now, if you look at the structures that we've got up here, anytime oxygen formed 2 bonds, like right here in water, that's 2 bonds, right? It's not a double, it's a single and a single, that's 2 bonds. Here it formed 2 bonds. Here it formed 2 bonds. When it formed 2 bonds, its formal charge came out to be 0. But over here, when it formed 1 bond, its formal charge came out to be -1. When it formed 3 bonds, its formal charge came out to be +1. Okay, but when it forms the number of bonds according to its Lewis dot symbol, it'll have a 0 formal charge. Now, does that mean that the formal charge of oxygen always has to be 0? No. You will encounter some structures where it has formal charges like this in the bottom right, +1s and -1s, and that is the structure. Okay, but you can use it to distinguish which one's better.